Hi everyone, my name is Jacob Pushy, and today I'm going to teach you how to make a ferrofluid and explain exactly how this works. For this experiment, we were instructed to gather ink toner, which I have here, rare earth magnets, which I have here, and mine are neodymium disc magnets, and vegetable oil, which I have here. And once our supplies are gathered, we place the toner in a cup along with the vegetable oil and use the magnet to demonstrate the magnetism of the fluid. And here I'm going to demonstrate that here. Now the toner's kind of colored my glass. You can't exactly see it, but if you look inside, you'd be able to see that there's some spikes. Now they're kind of subtle, so you have to kind of thin the liquid out like that, but they do work. Exactly what is happening when I mix the toner with the vegetable oil and place the magnet beneath them. So the ink toner, also used in laser printers, contains about 40% fine iron dust at a nanoscale, which usually has a diameter of around 10 nanometers or less. These nanoparticles of magnetite and hematite contain iron. The iron toner is mixed with vegetable oil to make a viscous colloidal liquid, also known as a ferrofluid. Therefore, ferrofluids are colloidal liquids made up of ferromagnetic particles with fluid that are usually organic, like oil and water. A ferrofluid is an oily liquid blended with microscopic particles of metal, like I said. It is combined with a liquid that we'll call a surfactant to prevent clumping. It forms such crazy shapes in the presence of a magnet because the metal particles try to align themselves along the path of the magnetic field. As the name suggests, ferrofluids are composed of ferromagnetic particles, a surfactant, and a carrier fluid, as we've mentioned before. Ferromagnetic particles are used because of their large magnetic permeability as compared to other classifications of magnets. Essentially, the resultant magnetic fluid is orders of the magnitude larger than the induced magnetic field, which becomes important when manipulating a ferrofluid under moderate and controlled magnetic fields. Typical ferromagnetic materials consist of iron, nickel, and cobalt-based metals, and are occasionally rare earth materials. Ferromagnetism is caused by a long-range atomic scale ordering the caused unpaired electrons to align parallel with each other in a domain. These domains, or regions of the magnetic alignment, are randomly oriented and confined within the bulk material, leading to a magnetic field of zero. However, under an external magnetic field, these domains align, causing an amplification of the applied magnetic field. These domains created under atomic scale long-range ordering may span over large numbers of atoms. However, to make a ferromagnetic material fluid, for our purposes, we would require melting of a metal. Under such conditions, typical ferromagnetic alloys have melting points in excess of the point when ferromagnetic properties transition to paramagnetic. This transition is denoted as the Curie temperature. So, for that reason, we're using the toner and the vegetable oil and our neodymium disc magnets that I have here. And as you can see, the magnetic forces align. And that is how you can easily make a ferrofluid at home. I hope you guys learned a lot, and thanks. Bye.